Hello everyone, welcome back. I'm your friend XO. Today we're going to learn the concept of rational exponents and radicals.
Rational exponents and radicals.
Rational exponents and radicals. Alright. You know, for some of you, you may think, well, this is ridiculous. Why you have to learn all those stuff? It seems like useless. Well, that's quite normal because people would always like to, make some benefits very quickly. But everyone wanna do that. So not everyone could make it. You have to find a way where only a few people would rather to go, and that's the way for you to get into success. Because if anyone could do, that must mean one thing, which is that thing is quite easy. It has no difficulty out there. So if it has no difficulty out there, why people would want you to solve it? They could find anyone else, right? Alright, enough talking. Let's get into it. Intro to rational exponents.
We already know a good bit about exponents. For example, we know if we took the number 4 and raised it to the third power, this is equivalent to taking 3 4s and multiplying them. Or you could also view it as starting with a 1 and then multiplying the 1 by 4, or multiplying that by 4 3 times. But either way, this is going to result in 4 times 4 is 16, times 4 is 64. We also know a little bit about negative exponents. So for example, if I were to take 4 to the negative 3 power, we know this negative tells us to take the reciprocal 1 over 4 to the third. And we already know 4 to the third is 64, so this is going to be 1/64. Now let's think about fractional exponents. So we're going to think about what is 4 to the 1/2 power. And I encourage you to pause the video and at least take a guess about what you think this is. So the mathematical convention here, the mathematical definition that most people use, or that frankly all people use here, is that 4 to the 1/2 power is the exact same thing as the square root of 4. And we'll talk in the future about why this is, and the reason why this is defined this way is it has all sorts of neat and elegant properties when you start manipulating the actual exponents. But what does the square root of 4, especially the principal root, mean? Well, that means, what is a number that if I were to multiply it by itself, or if I were to have two of those numbers and I were to multiply them times each other, that same number, I'm going to get 4. Well, what times itself is equal to 4? Well, that's, of course, equal to 2. And just to get a sense of why this starts to work out, well, remember, we could have also written that 4 is equal to 2 squared. So you're starting to see something interesting. 4 to the 1/2 is equal to 2. 2 squared is equal to 4. So let's get a couple more examples of this, just so you make sure you get what's going on. And I encourage you to pause it as much as necessary and try to figure it out yourself. So based on what I just told you, what do you think 9 to the 1/2 power is going to be? Well, that's just the square root of 9, the principal root of 9. That's just going to be equal to 3. And likewise, we could have also said that 3 squared is, or let me write it this way, that 9 is equal to 3 squared. These are both true statements. Let's do one more like this. What is 25 to the 1/2 going to be? Well, this is just going to be 5. 5 times 5 is 25, or you could say that 25 is equal to 5 squared. Now, let's think about what happens when we take something to the 1/3 power. So let's imagine taking 8 to the 1/3 power. So the definition here is that taking something to the 1/3 power is the same thing as taking the cube root of that number. And the cube root is saying, well, what number, if I had 3 of that number and I multiply them, that I'm going to get 8. So something times something times something is 8. Well, we already know that 8 is equal to 2 to the 3rd power. So the cube root of 8, or 8 to the 1/3, is just going to be equal to 2. This says, hey, give me the number that if I say that number times that number times that number, I'm going to get 8. Well, that number is 2, because 2 to the 3rd power is 8. Do a few more examples of that. What is 64 to the 1/3 power? Well, we already know that 4 times 4 times 4 is 64. So this is going to be 4. And we already wrote over here that 64 is the same thing as 4 to the 3rd. I think you're starting to see a little bit of a pattern here, a little bit of symmetry here. And we can extend this idea to arbitrary rational exponents. So what happens if I were to raise, let's say I had, let me think of a good number here. So let's say I had 32. I have the number 32, and I raise it to the 1/5 power. So this says, hey, give me the number that if I were to multiply that number, or I would have repeatedly multiply that number 5 times, what is that? I would get 32. Well, 32 is the same thing as 2 times 2 times 2 times 2 times 2. So 2 is that number that if I were to multiply it 5 times, then I'm going to get 32. So this right over here is 2. Or another way of saying this kind of same statement about the world is that 32 is equal to 2 to the 5th power.
Actually, this video didn't tell us much about it. Sign in to save your progress. I thought I would say sign in before. Alright, never mind, now we are in. So for this video, it didn't tell us much about the scene. Rewriting rows as rational exponents. What is that?
We're asked to determine whether each expression is equivalent to the 7th root of v to the 3rd power. And like always, pause the video and see if you can figure out which of these are equivalent to the 7th root of v.
Of course, I know the result of this, whether it's equivalent or not. Let's say for the first one, this is kind of ridiculous. I thought
v to the 3rd power. Well, a good way to
okay, so as far as I say, it should be just equal to with 3. Of course, that's the base. And then, if you're seeing it as a whole stuff, you would get something like this. So the answer is B.
figure out if things are equivalent is to just try to get them all in the same form. So the 7th root of v to the 3rd power, the 7th root of something is the same thing as raising it to the 1/7 power. So this is equivalent to v to the 3rd power raised to the 1/7 power. And if I raise something to an exponent and then raise that to an exponent, well then that's the same thing as raising it to the product of these two exponents. So this is going to be the same thing as v to the 3 times 1/7 power, which of course is 3/7. 3/7. So we've written it in multiple forms now. Let's see which of these match. So v to the 3rd to the 1/7 power, well that was the form that we have right over here, so that is equivalent. V to the 3/7, that's what we have right over here, so that one is definitely equivalent. Now let's think about this one. This is the cube root of v to the 7th. Is this going to be equivalent? Well, one way to think about it, this is going to be the same thing as v to the 1/3 power. Actually, no, this wasn't the cube root of v to the 7th. This was the cube root of v and that to the 7th power. So that's the same thing as v to the 1/3 power, and then that to the 7th power.
Alright, that's kind of boring, because we already know that. If I already know something, then I always would think that the scene is boring. I always, want to try to do something new. That's my habit, probably.
So right here, we've got 3 to the a power, or 8th power, I guess, is, I don't want to confuse it with the number 8. 3 to the a power is equal to the 5th root of 3 squared. And what we need to figure out is what would a be equal to? Let's solve for a, and I encourage you right now to pause this video and try it on your own. Well, if you have
Alright, so I say what I just said is he was asking us for solving this kind of problem, what is the a would be if we got an equation like this. Well, it's simple. We just have to do some transformation to let the new expression get a base of 3. Then we will be done. So how can we do that? At first, I want to rewrite the whole stuff for a little bit. For the whole stuff, for now, it should be something like this. Then we're gonna do it further. So gonna rewrite it again to make it look something like this, Then after that, we could say in the end, it's equal to 3 to the power of 1/2 times 1/5. So in this case, that would be equal to 3 to the power of 1/10. So in the end, as far as I would tell you, is that the a is equal to 1/10. This is the final answer. Okay, so it's just something like this, a equal to 1/10. Well, clearly we got some problem here, because the final answer, the correct answer is 2/5.
Video and try it on your own. Well, if you have a 5th root right over here, one thing that you might be tempted to do to undo the 5th root is to raise it to the 5th power. And of course, we can't just raise one side of an equation to the 5th power. Whatever we do to one side, we have to do to the other side if we want this to still be equal. So let's raise both sides of this equation to the 5th power. Raise both sides to the 5th power. Now this left-hand side, we just have to remember a little bit of our exponent properties. 3a to the 5th power. And if we want to just remind ourselves where that comes from, that's the same thing as 3 to the a times 3 to the a times 3 to the a times 3 to the a.
Alright, now I got it. So basically, if you wanna solve solve this kind of problem, you got two methods to do. And for us, we just use the second method, but unfortunately we get some error because I forgot something. For here, that will be equal to 3 to the 2's power, or 3 squared, then to the 1 over 2 power, then to the 1 over 5 power. So in this case, 2 times 1 over 2 would be just equal to 1, so they are cancelled out. In the end, we could get something like, 3 to the 1 over 5. Or we could do it in another way. So basically, what we need to do is to maintain the equality of that equation all the way through the process of transformation. So at first, we want to get rid of the square root of 5. How can we do that? Where we make each side of that, we raise each side to the 5th power, so we can get rid of the 5 root of 5 squared. So this one, that will be equal to 3 to the 5a power. Then for this one, that will be just equal to 3 to the 2's power. In this case, 3 is definitely equal for both cases, but the 5a, it has to be also equal to 2, so that the whole equation could maintain the equality. So in this case, the a would be just equal to 2 over 5. So that was interesting. I didn't know why this method worked, while my method didn't work. That's interesting. So I'm gonna ban it out. Well, my method is also working, since as you know, the a here and the 2 over 5 here, they are equivalent. Okay, after the math part, let me just have a look at or let's just learn some English sentences for explaining how to do the equation transformation.
To the 5th root of 3 squared. And what we need to figure out is, what would a be equal to? Let's solve for a, and I encourage you right now to pause this video and try it on your own. Well, if you have a 5th root right over here, one thing that you might be tempted to do to undo the 5th root is to raise it to the 5th power. And of course, we can't just raise one side of an equation.
Okay, so as first, if you want to say that you want to increase one number's power to a specific one, then you use the word raise. For example, you want to say, you want to raise this number 5 to the x power. What you need to say is just what I have said, okay?
To the 5th power. Whatever we do to one side, we have to do to the other side if we want this to still be equal. So let's raise both sides of this equation to the 5th power.
Okay, here's another sentence. A just raised each side of that equation to the 5th power. So in Haseman, the whole stuff right in here is called an equation.
Raise both sides to the 5th power. Now this left-hand side, we just have to remember a little bit of our exponent properties. 3a to the 5th power. And if we want to just remind ourselves where that comes from, that's the same thing as 3 to the a times 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 3 to the a. Well, what's that going to be equal to? That's going to be 3 to the a plus a plus a plus a plus a power, which is the same thing as 3 to the 5a power. So the exponent property here is, if you raise a base to some exponent and then raise...
Okay, here's again. So in this case, how do they call the number 3? They say the number 3 is the base of the expression, right? Let me just hear it again.
Raise a base to some exponent and then raise
a base to some exponent. So in Haseman, I think that the 3 is the base of that expression. Then the a is the exponent of that. So sometimes he would call it to the power of a, but in another time, he would just like to say the a is the exponent of that base 3. So this is just how they explain things, or how they describe things in English sentence. So in my case, or in my course, or in my video, I will not only teach you how to think stuff in a mathematical way, also I will tell you how can you explain it, or how can you use the English language to explain the whole stuff. So basically we got two stuff to do. One is to learn the logic, learn the mathematics stuff. Another thing which is very important to us is to learn how to use English to express our mind. They are both very important. Okay, let's get into the next one.
Properties of exponents, rational exponents.
Properties of exponents, rational exponents. Properties of exponents. Properties of. This is another next sentence model. Properties of something.
So we have an interesting equation here. Let's see if we can solve for k. And we're going to assume that m is greater than 0. Like always, pause the video, try it out on your own, and then I will do it with you. All right, let's work on this a little bit. So you could imagine that the key to this is to simplify it using our knowledge of exponent properties.
Well, so that's what we need to solve. For now, totally depends on our own knowledge. So here again, at the first step, I would say it's just an equation. What we need to do is to maintain the equation while be able to get the value of k in this case. So at the first, when I saw this, I got an idea.
Fraction.
I just forgot how to describe it. So basically, when I say there, this item looks like an fraction. So we could do something like this. We could say, we could rewrite it with m to the power of 7 over 9 minus 1 over 3, which is equal to m to the power of, we need to make them to have a common denominator. So for this case, that will be just 3. 7 minus 3 is equal to 4. So m to the 4 over 9. That's the left side. Then how about the right side? The right side, it's equal to m to the k over 9 powers. Then, since we know all those parts in that equation, they are equivalent. The n, they are identical. The line, they are identical. So the only different part is the key, and it's quite obvious that we could get the 4 is the key. So finally we get the answer. The key is equal to 4. Alright, so from this graph, as you could say, we got the right answer for sure. K is equal to 4. Alright, let's get into another video.
We've already seen how to think about something like 64 to the 1/3 power. We saw that this is the exact same thing as taking the cube root of 64. And because we know that 4 times 4 times 4, or 4 to the 3rd power, is equal to 64, if we're looking for the cube root of 64, we're looking for a number that number times that same number is going to be equal to 64. Well, we know that number is 4, so this thing right over here is going to be 4. Now we're going to think of slightly more complex fractional exponents. The one we see here has a 1 in the numerator. Now we're going to see something different. So what I want to do is think about what 64 to the 2/3 power is. And here I'm going to use a property of exponents that we'll study more later on. But this property of exponents is the idea that, let's say with a simple number, if I raise something to the 3rd power, and then I were to raise that to, say, the 4th power, this is going to be the same thing as raising it to the 2 to the 3 times 4 power, or 2 to the 12th power, which you could also write as raising it to the 4th power, and then the 3rd power. All this is saying is if I raise something to a power and then raise that whole thing to a power, it's the same thing as multiplying the two exponents. This is the same thing as 2 to the 12th. So we could use that property here to say, well, look, 2/3 is the same thing as 1/3 times 2. So we could go in the other direction. We could say, hey, look, well, this is going to be the same thing as 64 to the 1/3 power, and then that thing squared. Notice, I'm raising something to a power and then raising that to a power. If I were to multiply these two things, I would get 64 to the 2/3 power. We square it, and that is going to get me to 16. Now I'll give you an even hairier problem, and I encourage you to try this one on your own before I work through it. So we're going to work with 8 over 27, and we're going to raise this thing to the negative, and I'll try to color code it, negative 2 over 3 power, to the negative 2/3 power.
Okay, then for this problem, we need to solve it by our own. How can we do that? Let's say 8 over 27, the whole stuff to the negative 2 over 5 power. Well, this is a little bit tricky, but I guess I could handle it. So yeah, basically what I'm gonna do is to distribute the exponent to each part of that fraction. Well, that'll be equal to 8 to the negative 2 over 3 power, the whole stuff over the 27 to the negative 2 over 3 power. So in this case, we could do nothing, but now we could rewrite the whole stuff. For example, the 8, as we all know, it's 2 to the 3rd power, and for the whole stuff to the negative 2 over 3 power. Then for the for the 27, how can we do something with it? Or can we do something with it? To be honest, I don't know. Let's say, how about 3? 3 squared, it's equal to 9. 3 to the 3rd power, it's equal to 27. Was that correct? Yeah, that's correct. So basically, we could rewrite the 27 with 3 to the 3rd power, then to the negative to 2 over 3. Yeah, after that, we could do it something like this. We could say 2 to the 3 times negative 2 over 3, the whole stuff over 3 to the third times negative 2 over 3. In this case, it would be just equal to 2 to the negative 2 power and 3 to the negative 2 power. Then we extract the negative 2 power out. We will get something like this. Can we do something with the negative exponents? I don't know, but I think this is fine for now.
I encourage you to pause this and try this on your own. Well, the first thing I do whenever I see a negative exponent is to say, well, how can I get rid of that negative exponent? And I just remind myself, well, the negative exponent really just says take the reciprocal of this to the positive exponent. So this is going to be equal to, the reciprocal of this is 27. I'm using a different color. Let me use that light mauve color. So this is going to be equal to 27 over 8. Over 8, I just took the reciprocal of this right over here. It's equal to 27 over 8 to the positive 2/3 power. To the positive 2/3 power. So notice, all I did, got rid of the exponent and took the reciprocal of the base right over here. 8 over 27 is the base, negative 2/3 is the exponent. Now,
well, that's interesting. So what he just said is that the whole stuff right here, it is equal to 3 over 2 to the 2's power. Well, why that was 2? As we know, the 2 to the negative 1 power, it's equal to 1 over 2 to the 1's power. Or if we change the 1 to x, that will be the same stuff like this. And we could even rewrite it more. For example, here, we could just say 2 to the negative x power over 1. And you can even do more. For example, here, as you know, the 1 to any power, it's still 1. So you could rewrite it as 1 over 2 to the negative x power is equal to 1 over 2 to the positive power. Yeah, for now, I guess you could just understand what's happened here because they are somehow have the same pattern.
how can we handle this? Well, we've already seen that if I have a numerator to some power over a denominator to some power, and this is another very powerful exponent property, this is going to be the exact same thing. This is going to be the exact same thing as raising 27 to the 2/3 power, to the 2 over 3 power, over 8 to the 2/3 power, 8 to the 2/3 power. This is another very powerful exponent property. Notice, if I have something divided by something and I'm raising the whole thing to a power, I can essentially raise the numerator of that power over the denominator raised to that power. Now let's think about what this is. Well, just like we saw before, this is going to be the same thing. This is going to be the same thing as 27 to the 1/3 power, 27 to the 1/3 power, and then that squared, because 1/3 times 2 is 2/3. So I'm going to raise 27 to the 1/3 power and then square whatever that is. And that is going to be over, all this color coding is making this to switch a lot of colors. This is going to be over 8 to the 1/3 power, 8 to the 1/3 power, to the, and then that's going to be raised to the second power. Same thing we're doing in the denominator. We raise 8 to the 1/3 and then square that. So what's this going to be? Well, 27 to the 1/3 power, 27 to the 1/3 power is the cube root of 27. It's some number, that number times that same number times that same number is going to be equal to 27. Well, it might jump out at you already that 3 to the 3rd is equal to 27, or that 27 to the 1/3 is equal to 3. So the numerator, we're going to end up with 3 squared. And then in the denominator, we are going to end up with, well, what's 8 to the 1/3 power? Well, 2 times 2 times 2 is 8. So this is 8 to the 1/3 is 2. And then we are going to, and then let me do that same orange color. 8 to the 1/3 is 2. And then we're going to square that. So this is going to simplify to 3 squared over 2 squared, which is just going to be equal to 9 over 4. So if you just break it down step by step, it actually is not too daunting.
All right, that's exactly answer that we tried.
Fractional exponents can be a little daunting at first, so it never hurts to do as many examples as possible. So let's do a few. What if we had 25 over 9 and we wanted to raise it to the 1/2? Fractional exponents can be a little daunting at first.
Okay, here what he said is fractional exponents. So later on, when you see such an expression, you could just call it fractional exponents, something like that.
Let's do a few. What if we had 25 over 9 and we wanted to...
Here's another sentence. What he said is, what if we had something, then we would do something. That's a sentence, right?
To raise it to the 1/2 power. So we're essentially just saying, well, what is the principal square root of 25 over 9? So what number times itself is going to be 25 over 9? Well, we know 5 times 5 is 25, and 3 times 3 is 9. So why don't we just go with 5 over 3? Because notice, if you have 5 over 3 times 5 over 3, that is going to be 25 over 9. Or another way of saying this, that 5 over 3 squared is equal to 25 over 9. So 25 over 9 to the 1/2 is going to be equal to 5/3. Now let's escalate things a little bit. Let's take a really hairy one. Let's raise 81 over 256. 81 over 256 to the negative 1/4 power. I encourage you to pause this and try this on your own.
Well, I don't want to try it by my own, but I know how exactly what I'm gonna do to solve this problem. Well, at the first, when you say there's a negative sign on the components, on the exponents part, well, what you want to do is to get rid of that negative sign, then put the numerator into the denominator and put the denominator into the numerator. Just do a switch. Then if you say a fraction out there, what you really want to do is to take the denominator as the let's say square root or something like that. Then you add a square root of that kind of symbol to it, and you're done.
So what's going on here? This negative. The first thing I always like to do is I want to get rid of this negative in the exponent. So let me just take the reciprocal of this and raise it to the positive. So I could just say that this is equal to 256 over 81 to the 1/4 power. And so now I can say, well, what number times itself times itself times itself is going to be equal to 256? And what number times itself times itself times itself? Did I say that 4 times? Well, what number, if I take 4 of them and multiply, do I get 81? And one way to think about it, this is going to be the same thing. And we'll talk about this in more depth later on when we talk about exponent properties. But this is going to be the exact same thing as 256 to the 1/4 over 81 to the 1/4. You in fact saw it over here. This over here was the same thing as the square root of 25 over the square root of 9. Or 25 to the 1/2 over 9 to the 1/2. So we're just doing that over here. So we still have to think about what number this is. So, and this is a little bit of, there's no easy way to do this. You kind of have to just play around a little bit to come up with it. But 4 might jump out at you if you recognize that 16 times 16 is 256. We know that 4 to the 4th power, or you're about to know this, is 4 times 4 times 4 times 4. And 4 times 4 is 16, times 4 is 64, times 4 is equal to 256. So 4 to the 4th is 256, or we could say 4 is equal to 256 to the 1/4 power. Fair enough. Now what about 81? Well, 3 might jump out at you. We know that 3 to the 4th power is equal to 3 times 3 times 3 times 3, which is equal to 81. So 3 is equal to 81 to the 1/4. So this top number, 256 to the 1/4, that's just 4. 81 to the 1/4, that is just 3. So this right over here is going to be equal to 4/3.
Alright, here's a new video. Equivalent forms of exponential expressions.
What I hope to do in this video is get some practice simplifying some fairly hairy exponential expressions. So let's get started. Let's say that I have the expression 10 times 9 to the t over 2 plus 2 power times 5 to the 3t. And what I want to do is simplify this as much as possible and preferably get it in the form of a times b to the t. And like always, I encourage you to pause this video and see if you can do this on your own using exponent properties, your knowledge, your deep knowledge of exponent properties.
Fine, we'll try to solve it by our own. So basically what we need to do is to convert the yellow expression to the red expression. How can we do that? Well, at the first, I guess the 10 is equivalent to A because it doesn't have any t involved into it. Then what I'm gonna do is we need to put the two parts together. So let me do this. Line to the t over 2 plus 2. What is that? Well, how can we do it correctly? We could rewrite the 2 as 2 to the, as a 4 over 2. Then it could just become t plus 4 over 2. And then let's say for the line, it could be rewritten as 3 to the 2's power and the whole stuff to the t plus 4 over 2. Then we could multiply the two exponents together. Then we get a 3 to the t plus 4's power. Okay, in the end we could get something like this. But it still didn't solve our problem. I guess that's it. I am out of way for making it right. So I'm gonna watch the video now.
Alright, so let's work through this together. And it's really just about breaking the pieces up. So 10, I'll just leave that as 10 for now. There doesn't seem to be much to do there. But there's all sorts of interesting things going on here. So 9 to the t over 2 plus 2, So this right over here, I could break this up using the fact that, I'll just write the properties over here. If I have 9 to the a plus b power, this is the same thing as 9 to the a times 9 to the b power. And over here, I have 9 to the t over 2 plus 2. So I could rewrite this as 9 to the t over 2 power times 9 squared. Times 9 squared. All right. Now let's move over to 5 to the 3t. Well, if I have a to the bc, so you could view this as 5 to the 3 times t. This is the same thing as a to the b, and then that to the c power. So I could write this as, this is going to be the same thing as 5 to the third, and then that to the t power. And the whole reason I did that is, well, this is just going to be a number, and then I'm going to have some number to the t power. I want to get as many things just raised to the t power as possible, just to see if I can simplify this thing. So this character right over here is going to be 81. 9 squared is 81. 5 to the third power, let's see, 25 times 5, that's 125. So we're making good progress. And so the only thing we really have to simplify at this point is 9 to the t over 2. And actually, let me do that over here. 9 to the t over 2. Well, that's the same thing. That's the same thing as 9 to the 1/2 times t. And by this property right over here, that's the same thing as 9 to the 9 to the 1/2 times, or 9 to the 1/2, and then that to the t power. So what's 9 to the 1/2? Well, that's 3. So this is going to be equal to 3 to the t power. So this right over here is 3 to the t power. So now this is getting interesting. So I have the 10 out front. Times 3 to the t. Actually, let me write the 81 first. 10 times 81 times 3 to the t. So all I did is I just swapped the order that I'm multiplying. Times 125 to the t. Times 125 to the t power. Now, the 10 times 81, I could just multiply that out. That's going to be 810. And then what's 3 to the t times 125 to the t? Well, this is another exponent property at play here. Because if I have a times b to the t power, that's a to the t times b to the t. Or another way to think about it, if I have a to the t times b to the t, that's the same thing as a times b to the t power. And so over here I have 3 to the t times 125 to the t. So it's going to be the same thing as 3 times 125 to the t power. So this part of it, right over here, I could rewrite it as 3 times 125, and I'm going to raise that whole thing to the t power.
Alright, I didn't expect this. Well, that's quite interesting. At the first, this is a pretty new idea. I seems to be never know this before, I guess. That was a problem. I have no wondering why I couldn't, solve those problems when back into the school. Well, and here's another expression that I didn't know before. Come on, what is that? A to the t's power times b to the t's power is equal to a times b the whole stuff to the t power. That's sick. I don't know that. So based on that, let me just rewrite my final answer, because it's not a final answer. It's not the simplest expression that we could get from the original expression. Well, for this one, that'll be equal to 3 to the t's power times 3 to the fourth power, right? Yeah, that's correct. And then we get 5 to the third power to the t. So in the end, we could rewrite this as this. 5 to the third power. What is that? Okay, it's 125. We could do it like this to get the final result. But for some people, they just somehow remember the result of that. That's pretty stupid. Why they would like to remember that? Because that makes sense. You remember all those stupid things. Okay, when you look at this, what it should be, according to the theorem, it should be 3 times 125, the whole stuff to the t's power. So for some reason, if you don't know this if you don't know this equation or theorem before, you shall write it down to your notebook so that next time you could use it without any problem.
Let's get some practice solving some exponential equations. And we have one right over here. We have 26 to the 9x plus 5 power equals 1. So pause the video and see if you can tell me what x is going to be. Well, the key here...
Oh, God's sake. When I say such an equation, I have no idea how to solve the x for now. Oh, wait a minute. Maybe I have. Since we got the stuff we just learned. So maybe it could be something like this. 20 to the 9x power and times 20 to the 5th power. it's equal to 1. And then we could get 26 to the 9x power equal to 1 over 26 to the 5th power. And after that, how can we actually do it? How can we make progress then? Well, I was kind of running out of way. So we have used the first equation here. What about the second equation? Wait a minute. I guess I just found a way. So here we got a fraction on the right hand side. We need to get rid of that fraction. How can we do that? We could do something like this. It's equal to negative 5 to the negative 5 exponent. Yeah, after that we could say it clearly that the 9x would be just equal to negative 5. Then the x it would be equal to negative 5 over 9. That was quite simple.
Here is to realize that 26 to the 0th power is equal to 1. Anything to the 0th power is going to be equal to 1. 0 to 0th power we can discuss at some other time, but anything other than 0 to the 0th power is going to be 1. So we just have to say, well, 9x plus 5 needs to be equal to 0. 9x plus 5 needs to be equal to 0. And this is pretty straightforward to solve. Subtract 5 from both sides, and we get 9x is equal to negative 5. Divide both sides by 9, and we are left with x is equal to negative 5. Let's do another one of these.
Holy shit. So for here, the solution of his solution is even straightforward than me. What he did is, well, they say any number, if you get his 0 exponent, you'll get 1. So the line x plus 5 would definitely just equal to 0. Then he did some transformation, but I guess what he did is wrong. So let's say 9x is equal to negative 5. Then the x would definitely just equal to negative 5 over 9, which is exactly what we got just a minute ago. But clearly, what he said is x equal to negative 5, which is wrong. This should be the correct answer. I don't know why he did that. So it seems like even those genius, they are most likely would also make mistakes. So don't worry if you make mistakes. It's a way toward the success. Okay, so that's basically the today's learning, and I will see you guys in the next video. Bye.